right, well, I'm Frank Rahel, a faculty member at the University of Wyoming. And the areas that I'm interested in include invasive species and climate change, and particularly the nexus between those two. Ecologists like to think of filters that prevent or influence the distribution of organisms across the landscape. And we can think historically of filters that might have limited, say, this group of invasive species, and they could include things like cold temperatures, winter hypoxia or winter kill, low nutrient, and an unfavorable flow regime in a stream environment. And so they prevented these species from either colonizing or perhaps becoming abundant. And what climate change is going to do, of course, is reduce the effectiveness of some of these filters. We'll have warmer temperatures, we'll have reduced winter kill or reduced hypoxia in the winter. Because of eutrophication, we may have higher nutrient content in some of our water bodies, and perhaps our alterations of flow regimes might be more favorable. And I should say that most of our talks that I've heard today have involved the land. So I'm going to be focusing on aquatic environments, and my own particular area of interest is in fish. And so as climate change reduces the effectiveness of filters, we then have the ability for either colonization or expansion of these invasive species. Historically, our first reaction has been to try to resist change. And this is illustrated here with a stream system. Let's say if this was a trout stream, and with climate warming, it's becoming inhabitable for trout. So we might do things like plant riparian vegetation, remove livestock grazing, try to shade the water and improve the conditions. But as Gregor showed us this morning, we may get into situations where we're outside of the historic range of variability. And in that case, resistance simply might be futile. And one of the things that the RAD framework provides is some alternatives in terms of either accepting the changes and managing as best we can, or in directing changes to some new configuration. So this is a slightly different configuration of the RAD concept. But if we think we have a set of historical conditions that we typically managed for, and climate change is driving that system to some sort of new state, new set of conditions. Our first reaction is often to try to resist and restore those historical conditions as best we can. But there may be situations where we simply can't do that. It's just infeasible to try to recreate past conditions. So RAD proposes that one of the other options is to simply accept change. And we'll have a new conditions, and we'll try to manage as best we can within those conditions. And perhaps the most innovative part of the RAD framework is this idea of directing change. And that is, rather than just accepting what's going to happen, we'll try to intervene and create some new conditions that would be more desirable for humans. And I've been interested in how this could apply to fisheries management. And fisheries managers typically have had four major tools in their toolbox to try to affect change in fish populations. So historically, the first thing that managers did was stock. And in some cases, they were creating new fisheries. In other cases, they were enhancing existing fisheries. But it became apparent after a while that with unlimited harvest, that stocking wasn't going to solve all the problems. And so we moved into a phase of regulating the harvest, the number of fish, the size of fish, when and where one could fish. However, even in those circumstances with regulations, we began to realize that habitat was a very important part of maintaining a healthy fishery. And so we moved into an era of habitat improvements. And the idea here was generally to increase the carrying capacity so that the system could naturally produce more fish without having to rely on stocking or heavy regulations. And then most recently in the history of fisheries management, we've come to appreciate ecological interactions in aquatic systems. And so we've moved into an era of community manipulations. And this simply means that if we have a species of interest, say here, we're going to try to manipulate some other part of the food web or some other member of the community to try to increase or enhance this population. So we might deal with competitors, might reduce their populations. We might deal with predators on our species of interest, or we could go below the food web here and say do something to increase prey or overall productivity. So those are really the four major strategies that fisheries managers on inland waters have had to try to manage fish populations. And I'm interested in how those map onto the resist, accept, and direct framework. So if we create a table here, we have the resist, the accept, and the direct options, and then these four tools. And I'm not going to have time to go through the table, but let's just take stocking, for example. One of the ways that stocking could be used to resist change is to stock more fish to compensate for a lack of natural recruitment. If we are in the accept framework, then we might admit that conditions have changed to the point where stocking a species that's intolerant to the new conditions isn't financially feasible, and so we just stop and we accept that we don't have that fishery anymore. And direct, we may decide that the conditions are now so different that we need a new species in this system, and so we might stock something that's better adapted to the new conditions. So where in this framework might we intersect with the management of invasive species? And I think there are really three of these cells that deal with invasive species. And one of them involves habitat improvements. If we accept that climate has changed and we can't do anything about it, one of the things we can do to manage under these new conditions is to try to restore connectivity, to allow access to refugia, and then to allow populations to recolonize. And that's certainly been a major activity in inland fisheries management these days, removing dams to allow passage of fish, or where we can't remove the dam, perhaps it's serving some other function and we need to maintain it, we at least create passages, fishways, basically a stair-stepping aquatic staircase, and allow passage of fish. Well, when we're allowing movement of the desirable species, we, of course, are also allowing movement of undesirable species. And that's the major trade-off here in trying to balance this increasing connectivity for the species we want and decreasing connectivity for the species we don't want. An example of this unintended effect in the Great Lakes area, we have the invasive round goby. It's become quite abundant in Lake Erie. There was a dam removal project on the Ottawa River. They removed one of the dams, and immediately the round goby colonized upstream. And the problem is it has negative effects on some of the native fishes, some of the darters and sculpin species. So in this case, restoring connectivity had its good points, but it also definitely allowed an invasive fish species to expand. If we think of a community manipulation in terms of trying to resist an invasive species, well, we can do various things to try to suppress an undesirable species that might in fact be favored by climate change. Or we can do the opposite of restoring connectivity, and we can intentionally fragment systems to prevent colonization by non-natives. And let's explore those a little further. So in terms of preventing the introduction or extirpating populations or suppressing populations of undesirable species, we'll start with preventing introduction. One of the ways we attempt to do this is by simply having bans on undesirable species. Most states have a list of species that it's illegal to possess. For example, in the state of Washington, it's against the law to have northern pike in your possession and to move them around. And in fact, if you're caught doing that, you could face a $5,000 fine and a year in prison. So that certainly will get the attention of people that get caught doing these sorts of things. And coupled with that, many states now have pretty intensive surveillance and early control measures for some aquatic species. Here in the Rocky Mountain West, where I am, we have boat inspections for invasive species. So if you bring a boat into the state, you have to stop at a check station along the way, along highways, and have your boat inspected, particularly worried about zebra mussels and quagga mussels and some aquatic plants. And if your boat is found to contain any of those, then you go through a decontamination procedure. and you're given a sticker indicating you have a clean bill of health. And people who don't have those stickers on their boats, again, are subject to fines. So that's trying to prevent the introduction in the first place. Once a species has become established, then we move to trying to extirpate those populations. And in fisheries management, we have some things we call pesticides. They're fish toxicants. Rotenone being administered here is a common one. And the idea is then that we're going to try to remove all of those invasive individuals. A good example involves the brook trout, which is not native to the Western US and is considered an invasive species in many areas because it has a harmful effect on the native cutthroat trout. And where this intersects with climate change is that brook trout are generally favored by warming, and their negative effects are increased on the cutthroat trout. So we're going to see more of an urgency to try to control brook trout populations as we continue to get warm. And in situations where we can't really eradicate, then we move to periodic suppression of an undesirable species. We can do that through what we call mechanical removal. This may mean electrofishing and taking out the fish we don't want, putting back the fish we do want. It can be netting. And one of the examples that I really enjoy is the crowdsourcing of control of northern pike. And along the Columbia River, the states there have created a bounty system where they will pay you for catching northern pike, and it depends upon how many you catch. And they have some tagged fish that are worth a lot of money. And the issue here, and this is a very interesting case because the northern pike minnow is actually a native fish to that system, but its populations have boomed with the creation of reservoirs, and lots of modeling studies have shown that as temperatures warm and its metabolic rate increases, it's going to be consuming more and more salmon. So there's going to be more and more of a need to control their populations. And like I say, we're doing that using a crowdsourcing model. And the other way that we might manage invasive species is to intentionally fragment systems to prevent colonization. This is a stream in Wyoming where our state agency has created an artificial barrier across the stream. Upstream, there's native cutthroat trout, and downstream there are brook trout, and this barrier then prevents the upstream migration of the brook trout and therefore the negative effects that they would have. Here's another system that probably represents the epitome in terms of a balance between fragmentation and reconnection. This is a fish walkway on the Gunnison River in Colorado. Fish can work their way up through this aquatic staircase, and then they're caught in a holding area up here. So this is a barrier to movement. Fish can get around it, but because they're caught here in a holding area, biologists can check what's in that area and then remove the unwanted fish and allow the desirable fish to continue upstream. So again, sort of the best compromise between preventing movement of unwanted fish and allowing movement of wanted fish. If we go back to our table here and look through a community manipulation, that might involve accepting that change has happened. And that is to kind of make lemonade out of lemons. If we have these non-natives in the system, perhaps there are ways that we can actually accept them and promote their use if in fact we're not going to be able to get rid of them. And the best example I think of is the common carp. It is a non-native that is become quite widespread, will probably continue to expand and increase in abundance as lakes become warmer and more eutrophic. But in fact, there are groups of anglers that are out there promoting a recreational fishery for these fish. There's actually something called the American Carp Society. You've probably heard of Trout Unlimited or the Bass Anglers Sportsmen's Association that promote trout or bass fishing. This group is promoting carp fishing. And if you are really into this, you can actually hire a guide to take you out. You can spend a day fly fishing for big carp. And some of my students have done that, and they said it was absolutely a blast trying to catch these big fish on flies. Although it's going to cost you a pretty penny to do that. So in conclusion, I hope I've given you a little bit of things to think about in terms of how this resist, accept, and direct framework might be applied within the context of managing freshwater fish populations in the face of a changing climate. And I'll end there.